Hi, this is Ramachandran from onlinemathforall.com. In this video, we are going to see nature of the roots of a quadratic equation. We all know about the general form of a quadratic equation, that is ax square positive bx positive c is equal to 0. For any quadratic equation, we'll have two roots. Since the highest exponent of any quadratic equation is 2, we'll have two roots for any quadratic equation. Our topic is how the two roots of a quadratic equation going to be, whether they are real or imaginary, and the two roots are going to be rational or irrational. So this is what is going to be discussed. So that is what is said by our topic, nature of the roots of a quadratic equation. And we all know how to solve a quadratic equation. We have three methods to solve any quadratic equation. That is, first one is factoring, the second one is quadratic formula, and the third one is computing square method. Now I am going to consider the second method to solve any quadratic equation, that is quadratic formula. So we all know quadratic formula. So quadratic formula is x is equal to negative b positive or negative square root of b square negative 4ac over 2a. This is a quadratic formula. In this quadratic formula, we have two roots. Let us consider the sign which is between negative b and square root. We have positive or negative. Now I am going to separate the two roots by using this sign. So x is equal to negative b positive square root of b square negative 4ac over 2a. Then the second root is negative b negative square root of b square negative 4ac over 2a. So we get two roots from this formula. So I just consider the sign in between negative b and square root. So between these two terms I find the sign positive or negative. I just wrote one root for positive sign. I wrote another root for negative sign. I hope the student will be able to understand how I got two roots from the quadratic formula. Now we can consider the part that is inside the square root, b square negative 4ac. The same we have in the another root also, that is b square negative 4ac. So this b square negative 4ac is called discriminant. Why we say this b square negative 4ac is discriminant? Because it decides the nature of the roots of a quadratic equation. So that is based on the value of b square negative 4ac, we will decide whether the two roots are real or imaginary. And again we will consider the same value b square negative 4ac, we will decide whether the two roots are rational or irrational. So all those things are decided by the value of b square negative 4ac. That is why it is called as discriminant. Okay, how it works to find nature of the roots of a quadratic equation. So let us discuss in detail on our next page. Okay, so before we are going to start discussing nature of the roots of a quadratic equation, first let us come to know what is real, what is imaginary, rational, irrational. Let us discuss all these four terms and then we can go back to our original concept and decide whether the two roots of a quadratic equation are real or imaginary, and also the two roots of the quadratic equation are rational or irrational. So first let us come to know what is imaginary. Okay, we all know about the numbers with square root. Now I am going to consider the number inside the square root with negative sign. For example, negative 5. So in this number we have a negative sign inside the square root. Whenever we have a negative sign inside the square root, that is called imaginary number. Okay, except this case, all other numbers are real numbers. For example, negative square root 5. So this is real, because what is the difference between this one and this one? So in the first case, in the imaginary case, we have a negative sign inside the square root, but in real case we have a negative sign outside the square root. So the second number, negative square root 5, or simply square root 5, square root of 4, 3 by 5, negative 0.5, all other numbers like this are real numbers. So imagine a number, we have to understand a simple thing to understand about the imaginary number. That is, if you have negative sign inside the square root, that is called imaginary number. Otherwise it will be a real number. I hope now the students will be able to understand what is real and what is imaginary. Now let us come to know about rational and irrational. So to know about irrational number, let us get a number with square root. Square root of 5, square root of 4, square root of 1.21. So what is the value of square root of 5? We'll have 2 point and we'll have lots of digits after the decimal. That is infinite number of digits after the decimal. And for 4 we get exactly 2. For 1.1 we get exactly 1.1. Okay, now let us consider the first case. In this case, that is square root of 5 is equal to 2 point something. In this case, in the result of the number with square root, that is square root of 5 is equal to, we get infinite number of digits after the decimal. Whenever we get this kind of numbers with square root, so that is called irrational. In detail, instead of the square root, if you have perfect square, that number cannot be irrational. That number would be an rational number. So for example, let us consider the numbers like 4, 9, 16, 25. So when you get result for these numbers, for the first one, square root of 4, we get 2. For the second one we get 3. For the third one we get 4. For the fourth one we get 5. So we don't have infinite number of digits after the decimal in all these results. So all these numbers with square root are rational numbers. In case for a number with square root, we get the result with infinite number of digits after the decimal, like root 5. Or you can consider lots of numbers like this, root 6, root 7, root 8. So for all these numbers with square root, we will be getting the result with infinite number of digits after the decimal. So all these numbers are called irrational numbers. I hope now the students will be able to understand the difference between rational and irrational. So when they have a number with square root, so it's very clear, if you have a perfect square inside the square root, definitely it would be a rational number. In case the number inside the square root is not a perfect square, like 5, 6, 7, 8, so definitely those numbers would be irrational numbers. Okay, now we can move to the original problem. Already we have the two roots for a quadratic equation, that is x is equal to negative b positive square root of b square negative 4ac over 2a, and the second root is negative b negative square root of negative b negative square root of b square negative 4ac over 2a. These are the two roots we have. Okay, already I told you that based on the value of b square negative 4ac, we will decide whether the two roots of a quadratic equation are real or imaginary. And then second condition, the same value again will be considering b square minus 4ac. We will decide whether the two roots are rational or irrational. Now let's move to the next page. First I am going to consider I assume the value of b square negative 4ac is equal to 0. Then the two roots of a quadratic equation will be x is equal to negative b positive square root of 0 over 2a, and the second root is going to be negative b negative square root of 0 over 2a. So x is equal to negative b, the square root of 0 is nothing but 0, so negative b positive 0 over 2a, and negative b negative 0 over 2a. X is equal to, so positive 0 and negative 0 we don't have to consider, so we will get negative b over 2a, negative b over 2a. See the result. When b square negative 4ac is equal to 0, we get the two results, negative b over 2a, negative b over 2a. That means the two roots are same. And here we don't find square root. We don't find square root, and also only if we find square root and we have a negative sign inside the square root, that is called imaginary, otherwise real. Okay, so we don't have square root and we don't have negative sign inside the square root, so this is real, and also they are same. And only if you have square root and we get the result with infinite number of digits after the decimal, that will be considered as irrational. But we don't have square root, so we don't need to worry about whether it is irrational. So definitely the two roots are rational. So in this result we can say the roots are real, equal and rational. So I hope now the students will be able to understand how these two roots are real, equal and rational. The second point is very clear because the two roots are looking same, negative b over 2a, negative b over 2a. And how we decide the two roots are real? Because we don't have square root and we don't have negative sign inside the square root. So we can decide the roots are real. Since we don't have square root for both the roots, we decide the roots are rational. Okay, now we can move to the second case. Now I am going to consider the part b square negative 4az greater than 0 and also a perfect square. So the value of b square negative 4az is going to be greater than 0 and also the value of this one is a perfect square. Okay, I assume b square negative 4az is equal to 16. How I got this 16? Because I just assumed, for an example, I assumed the value of b square minus 4az is equal to 16. It was assumed by myself. Since we have mentioned it has to be a perfect square, I consider the value 16. So not only 16, you can consider any perfect square like 9, 25, 49, 64, 81, 100, 121. We can consider any perfect square. I assumed the value of b square minus 4 is equal to 16. Now again we can take the two roots of a quadratic equation, that is negative b, positive square root of b square minus 4az, but here the value of b square minus 4az is 16 over 2a. Negative b, negative root 16 over 2a. So x is equal to negative b, positive, the square root of 16 is 4 over 2a, and negative b, negative, the same things, the value of square root of 16 is 4 over 2a. Now see these two roots, negative b, positive 4 2a over 2a, negative b, negative 4 over 2a. So obviously the two roots are not equal. So we say the two roots are unequal. And we don't have square root, we don't have negative sign inside the square root. So the two roots are real. And also since we don't have square root here, the two roots are rationals. So we decide when b square minus 4az over greater than 0 and also a perfect square, we say the roots are real, unequal and rational. I hope the students will be able to understand this part clearly. Okay, now let's move to the third case. B square negative 4ac is greater than 0 but not a perfect square. In our previous case we took b square minus 4ac was greater than 0, a perfect square, but in this case it's not a perfect square. So we can assume any value for b square negative 4ac, but it should not be a perfect square. So I assume b square negative 4a is equal to 5. Now we can take the two roots of a quadratic equation, that is negative b, positive, square root of b square negative 4ac. Instead of that we can take 5 over 2a. Negative b, negative square root of 5 over 2a. So clearly these two roots are not equal because we have positive root 5, we have negative root 5. So the two roots are unequal. And one more important thing, we have square root in both the roots, but instead of the square root we don't have negative sign. So clearly the two roots are real. So far two things we have decided, real and unequal. And we have square root of 5. So when you get result for square root of 5, you will be getting 2 point something, that is you will get infinite number of digits after the decimal. So clearly both the roots are irrational. So the decision is real, unequal and irrational. So So I hope the students will be able to understand this particular part clearly. Now we can move to the fourth case. So the fourth case is b square negative 4ac is less than 0. Here we don't have to consider whether b square negative 4ac is going to be perfect square or not a perfect square when it is less than 0. Okay, we can consider any value for b square minus 4ac, but it has to be less than 0. I assume the value of b square negative 4ac is negative 7, any number with negative sign. Now let us take the two roots of a quadratic equation, that is negative b positive negative 7 over 2a negative b negative of negative 7 over 2a. So clearly in both the roots we have a negative sign inside the square root. So a single result can be given for this one is the roots are, and also one more important thing, the roots are unequal and imaginary. The roots are imaginary. The only thing we can say for this one, imaginary and unequal. So I hope now the students will be able to understand clearly how the two roots of a quadratic equation going to be real or imaginary or rational or irrational. Okay students, for more videos like this please visit www.onlinemathforall.com. Thank you.